Let's try to understand about allied angle. So two angles, they are said to be allied if the sum or difference of two angles is either 0 or a multiple of 90 degrees. Meaning, we will start with an example. Let's say we have an angle 30 degrees. We'll try to find out the allied angles of 30 degrees. So we can consider negative 30 degrees. So this is going to be an allied angle of 30 degrees. The reason behind this is when we add 30 degree with negative 30 degrees, then we are going to get 0, right? Then we can have 60 degrees. So 60 degrees, this is an allied angle of 30 degrees. That's because when we add 30 degrees and 60 degrees, which gives us 90 degrees. So 60 degrees is also an allied angle of 30 degrees. Then we could have negative 210 degrees. So negative 210 degrees is an allied angle of 30 degrees because if we take 30 degree and add negative 210 degrees to it, this is going to give us negative 180 degrees, and negative 180 degrees, that's simply 2 times negative 90 degrees, or we can say it's a 2 times the multiple of 90 degrees. So that is how we can define allied angles. So if we to generalize it, if we start with an angle theta, then negative theta is an allied angle of positive theta. Then we can consider 90 degrees plus or minus theta. This is also going to be an allied angle of theta. We can have 180 degrees plus or minus theta. So that could be an allied angle of theta. We could have 270 degrees plus or minus theta. That could be an allied angle of theta. We could have 260 degrees plus or minus theta. That could be an allied angle of theta as well. And we have measured all the angles in terms of degrees. We can also convert it to their respective radian measures. Now 90 degree will be pi over 2 plus minus theta. 80 degrees will become pi radians plus or minus theta. 270 degrees will be 3 pi over 2 radians plus or minus theta. And 360 degrees will be 2 pi radians plus or minus theta. And then the sum or the difference of the two allied angles is going to be either 0 or a multiple of pi over 2 radians. Now why allied angles are very important? Because for instance, let's say we know the value of sine 30 degrees, sine 60 degrees, sine 90 degrees. It's very easy to obtain the value of sine 30. That means for angle theta lying between 0 and 90 degrees, we can easily find out the value of sine or cosine or all the remaining trig functions. But the moment we are given a very huge angle, for example, let's say sine 700 degrees, then this is the case when it becomes very important to understand the concept of allied angles. So we will learn different techniques to find out the value of 700 degrees, but let's try to understand the meaning of each of the angles. So we'll first begin with negative theta. That means we will start with an angle theta and we'll try to express it in terms of its allied angle negative theta. So we'll try to find out the trigonometric ratios of different trig functions such that their angle is given in terms of negative theta instead of theta, and we'll try to represent in terms of positive theta. So let's begin. So here we have our coordinate system. It's a Cartesian coordinate system, and we are going to begin by considering a revolving ray, and this ray starts from the OX axis. Now since it is revolving, we are going to consider revolving in the anti-clockwise fashion. So let's say it is revolving in the anti-clockwise fashion, and it makes an angle theta with the x-axis. So here clearly we can say that angle XO, we're going to consider a point P on the ray such that XOP, that equals to the angle theta. So it's a positive angle because we are revolving in the anti-clockwise fashion. Now the point P that we have chosen on this ray such a way that we are going to drop a perpendicular line on the x-axis and call it PM. Now here PM is chosen in such a way that let PM that has a length of x and OM has a length of y. That in that case the coordinates of point P will be x comma y, which means this implies that OP, this is going to have a length, so we can use the Pythagoras theorem. It will be square root of x squared plus y squared, or we can simply denote it by the radial distance r for simplicity. Here we can define the sine theta. So because we know that sine theta, that's the ratio of the perpendicular PM to that of the hypotenuse OP, which will be equals to, so our PM, that's the y value divided by r. So let's call it equation number 1. Now, we started off with the revolving ray, which was originally lying on the OX axis. We'll start with the same revolving ray, and this time we are going to revolve it in a clockwise fashion. So it goes in a clockwise fashion and makes an angle theta with the OX axis, but since this is going in a clockwise fashion, we have to consider negative theta. This is by sign convention. And similarly, we're going to consider another point. So this time we're going to call it P prime on this new ray and drop a perpendicular on the OX axis. Now, clearly here, angle XOP prime. So that's negative theta. We're going considering this negative theta, and so we'll start with OM. So OM, this is still going to be equals to X, and P prime M. This time P prime M, we're choosing in such a way this has a value of negative Y, meaning that the coordinates of P prime will be X comma negative Y. Now that we have P prime M, we can also find out the value of OP prime. The OP prime will be square root of X squared plus negative Y squared. So it's still going to be equivalent to R. Now that we have the value of OP prime, we can define sine negative theta. We are considering the triangle OMP prime, which is right angled at M. So here in so let me write down the name of the triangle here. So in right angle triangle OMP prime, so we can define sine negative theta. So sine negative theta, that's the ratio of the perpendicular P prime M divided by the hypotenuse, which is OP prime. So P prime M, so defined, that's negative Y, divided by OP prime. The OP prime, that's R. So this is equation number 2. Now, using equation 1 and 2. So in equation number 2, we have obtained the sine of negative theta. So that's equals to negative Y over R. Now what's Y over R? That's already defined as sine theta. So sine of negative theta came out to be negative times sine of theta. So that means sine of the allied angle of theta, which is negative theta, this came out as negative sine theta. Fine. Now that we have the value sine theta, sine negative theta, let's define cosine theta. So from this triangle, so cosine theta, so first we will have to consider the upper triangle. So upper triangle, we have PMO. So here in PMO, cosine theta. So cosine theta, that's the base over the hypotenuse. So our base here is OM divided by the hypotenuse, which is OP. The OM we have already defined, that's X. So we have X over R. Then coming to the lower half of the triangle. So in the lower half of the triangle, that is P prime MO. So here we can define cosine of negative theta. So cosine of negative theta, so that's equals to OM over the hypotenuse OP prime. So that means we have X over R. Now in this case, we can say the cosine theta and cosine of negative theta both have a value of X over R. So in this case, we can say that cosine of negative theta, that's equals to positive cosine theta. Now that we have the value of cosine theta as well as sine theta, we can also define tangent theta. So tangent of negative theta, so this should be the ratio sine negative theta divided by cosine negative theta. Now we have already defined the sine of negative theta is negative sine theta, and cosine of negative theta, that's simply positive cosine theta, which gives us negative sine theta over cosine theta. The ratio sine over cosine, that's the tangent function. So we have negative tangent theta. The tangent of negative theta, that's negative tangent theta. Since we have sine theta, we can also define its reciprocal, which is the cosecant theta. So we have cosecant of negative theta will be 1 over sine negative theta. So sine negative theta means we have negative of sine theta, and then 1 over sine theta, that becomes negative cosecant theta. So we have found out that cosecant of negative theta will be negative cosecant theta, and secant negative theta, so that will be equals to 1 over cosine of negative theta. Cosine of negative theta is simply positive cosine theta, so this will be equivalent to secant theta. So let's note down everything. So here we have finally obtained that sine of negative theta, in terms of its allied angle theta, it will be the negative sine theta. Cosine of negative theta, when we write it in terms of its allied angle theta, we get cosine of theta. tangent of negative theta will be negative tangent of theta. Then we have secant of negative theta, that will be positive secant of theta. That's because cosine of negative theta is positive cosine of theta. Cosecant of negative theta will be negative cosecant of theta. And one more, cotangent of negative theta will be negative cotangent of theta. Right. So this is how we can define the angle theta in terms of its allied angle, positive theta. In the next one, what we'll do, we'll try to express the angle 90 plus or minus theta in terms of theta. So let's do that as well. So now we want to show the trigonometric ratios of the angle 90 degree minus theta in terms of its allied angle, that is theta. Now what we'll do, we'll begin with a revolving ray that first lies on the OX axis. Then we are going to rotate it anti-clockwise. So this is our new ray, and such that it makes an angle theta with the OX axis. Here we will have a point P on the ray, and we are going to drop a perpendicular on the x-axis and going to name it PM. Next, what we'll do, we're going to consider the same rotating ray, and this time we're going to rotate it by some other angle such that this new ray, the new position of the ray, is going to make an angle theta with the OY axis. Magnitude wise, it's making a same angle theta with the Y axis. Now geometrically speaking, that means the angle XOY, that's 90 degrees, because the x's are always at 90 degree at right angles with each other. So what we need is this particular angle. So this angle is what? The total angle we have 90 degrees, and from here if we subtract theta from it, then this particular angle, this value is going to be 90 minus theta. So this is what we're interested in. So we are going to consider another point P prime on this new ray, and from this point we are going to drop another perpendicular P prime M prime on the OX axis. Now let me do one thing. Let me drop another perpendicular P prime N prime on the OY axis. Now here, using standard geometrical methods, we can show that triangle PMO, which is right angle at angle M, this is congruent to the triangle P prime N prime O. That's because we have the same angle theta. This is true because angle POM, which is theta, so that's equals to angle P prime ON prime. So this is equals to theta. And also we have our right angle triangle PMO equals to angle P prime N prime O. So this is 90 degrees. And here we've chosen the point P prime on the ray such a way that the distance ON prime, that's equals to OM. So this is very important here. This is how we have chosen the point P prime and P. And once these three criterions are met, then we can easily say that the two triangles are congruent to each other. So now we can have OM prime, that's going to be equals to PM. So PM, so we're going to define PM. So this length, let this be equals to Y, and OM, let this be equals to X. So let's write it down. So let OM be equals to X and PM be equals to Y, which implies we can also say, so since our OM that's equivalent to ON prime, the ON prime will be equals to X, and M prime, that was, so OM prime, that's PM, so PM will be equals to Y. Now let's define the distance OP as well as OP prime. So OP, that's defined as square root of OM squared plus PM squared by using the Pythagoras theorem. So OM, which is square root of X squared plus PM squared, so that's Y squared. And we have OP prime. The OP prime, for this we're going to consider the triangle OP prime N prime. So here we have square root of ON prime squared plus N prime P prime squared, which will be equals to, so ON prime we have already defined as X squared plus N prime P prime. So N prime P prime, that's OM prime, which is equals to Y squared. So here we can say that OP will be equals to OP prime, which is square root of X squared by Y squared plus Y squared. So let's consider by R, say that they're equal to each other. Now what we can do, we will consider the triangle PMO. So in triangle PMO, so let's begin by first defining sine theta. So sine theta will be equals to, so we know the sine theta is PM divided by OP. So PM, we have already defined PM is Y, so we have Y over R. So this is the value of sine theta. We're going to label this as number 1. Then we'll also find out the value of cosine theta. So cosine theta is OM over OP. The OM value, so that's X, so we have X over R. So this is number 2. Next, what we'll do, we will consider the triangle. Now this time we're going to consider the triangle P prime OM prime. So let's do that. So in triangle P prime, M prime and O. So in this triangle, we are going to find out the angle sine 90 minus theta. So here by the definition of the ratio of sine, the ratios will be P prime M prime, that's the perpendicular divided by the hypotenuse. So our hypotenuse will be OP prime. Now what's P prime M prime? So P prime M prime, so this side is equals to ON prime, and this value we have already defined, so that's equals to X. So we have X divided by OP prime, and we have already defined OP prime, so that's given by R. So sine 90 degree minus theta, so that's equals to X divided by R. But according to equation 2, X divided by R, that is cosine theta. So that means sine 90 minus theta will be equivalent to cosine theta. So sine 90 minus theta, so 90 minus theta is the allied angle of theta. In terms of theta, we will get cosine theta. Again, we're going to using the same triangle in triangle. So let me write it here. In triangle P prime M prime O, so we're going to define cosine of 90 degree minus theta. So 90 degree minus theta, so that's going to be equals to cosine is the base over hypotenuse. So base is OM prime divided by the hypotenuse, which is OP prime. So what is OM prime? So OM prime, we have defined this value as Y. So we have Y divided by OP prime. So OP prime, that's R. So we have Y over R. And we have also defined it Y over R as nothing but sine theta. So this will be equals to sine theta. Hence, we can show that cosine of 90 minus theta, so that's equals to sine theta. Now that we have the value of cosine and sine, we can find out the other trigonometric ratio. So let's first note it down. So we have obtained that sine 90 minus theta, so that's equals to cosine theta. And then we have cosine of 90 minus theta, so that's equals to sine theta. Fine. We know that cosecant of 90 minus theta, so that's equals to 1 over sine 90 minus theta, because cosecant function, that's the reciprocal of the sine function. So we have sine 90 minus theta, so that's given by cos theta. So we have cosine theta, and the reciprocal of the cosine function is secant theta. So that means cosecant of 90 minus theta, that's secant theta. Coming to secant 90 minus theta, so secant of 90 minus theta, that will be equivalent to 1 over cosine of 90 minus theta. And cosine of 90 minus theta is sine theta. So 1 over sine theta, and this reciprocal is defined as the cosecant function. So we have cosecant of theta. So secant of 90 minus theta, so that's equals to cosecant of theta. Then we come to tangent. So we have tangent of 90 minus theta. So this will be equals to the ratio sine over cosine. So we have sine of 90 minus theta all divided by cosine of 90 minus theta. So sine 90 minus theta, we have already defined that's cosine theta. So we have cosine theta over sine theta, which will be the cotangent function. So tangent of 90 minus theta, that will be cotangent of theta. Now, we'll find out the value of cotangent of 90 minus theta. So cotangent of 90 minus theta, that's the ratio of cosine of 90 minus theta whole divided by sine 90 minus theta, which will give us sine theta divided by cosine theta, and the ratio sine over cosine is the tangent function. So we have tangent of theta. So hence we have defined the allied angle 90 minus theta of each of the trigonometric functions with respect to theta, or in terms of theta. At this time, we want to express the trigonometric ratios of the allied angle of theta, which is 90 degrees plus theta. So first we will begin by considering a revolving ray which starts out by lying on the OX axis. Then let's say it rotates in the anti-clockwise fashion, making an angle theta with the OX axis. We're going to consider a point P on it and drop a perpendicular line on the OX axis and name it PM. Fine. So here let's first state that OM, that's X, and PM is Y, which means we can immediately define the coordinates of point P. That will be X comma Y. Now we're going to consider another ray which also starts out from the same initial position, which is OX. This time it rotates, let's say first by the same angle theta. So this is a second ray which also starts out from OM and it starts rotating by an angle theta first, and once it reaches the angle theta, it's going to make another angle 90 degrees starting from theta. So that means we are going to draw a ray which is perpendicular to the previous ray, such that the new ray, this is going to make an angle theta plus 90 degrees. So this angle is 90 degrees plus theta. Right. So this is the second ray that we're discussing. Now let's consider another point P prime on this new ray, the second ray, and we're going to drop a perpendicular line on the OX prime axis. So that's M prime. Now that we have defined the angle 90 degree plus theta, which is XOP prime, we can also find out the angle OP prime M prime. This angle must be equals to theta. That's because if we consider the triangle in triangle OM prime P prime, so clearly MOP prime, so that's going to be the external angle, which must be equals to the sum of the two opposite interior angles. That means OM prime P prime plus M prime P prime O. Fine. Now we have already defined it MOP prime, so angle MOP prime, that's equals to 90 degrees plus theta, which will be equals to angle OM prime P. So OM prime P, that's our 90 degrees plus angle M prime P prime O. So when we solve for this, we're going to get M prime P prime O, which is the angle P prime. So that will be equals to theta. So we have defined the angle theta. Now also we can show that, which I'm leaving as an exercise for you to try out. We can show that a triangle OMP. So this triangle is congruent to triangle OM prime P prime. So since they're congruent to each other, here we have to be a little bit careful with our sides. So OM will be equals to, no, not OM prime, but it will be equals to M prime P prime. Now since OM, we have already defined this as X, so M prime P prime, this value is X. We can also say that MP, so this will be equals to OM prime. And since our MP, which is equals to Y, so OM prime, so that will be, this value will be magnitude wise equals to Y. Fine. So what's the coordinate of P prime? So the coordinate of P prime will be the X coordinate. So X coordinate is OM prime, which will be Y, but we have to use negative Y here. The sign is very important because we are lying on the negative X axis, comma. Then we have the Y coordinate. So Y coordinate will be P prime M prime, which we have defined this as X. So this will be positive X. So we'll start with first the triangle. So in triangle PMO, so in this triangle, let's first define sine theta. So sine theta is going to be equals to, so we have PM over OP. So PM, we will define it by, so we have already defined as Y, and OP, which is the radial distance of point P from the origin. So that's R, labeled as a number 1. Then we have cosine theta. So cosine theta is OM over OP, which will be equals to X over R. So this is going to be number 2. We'll use 1 and 2. Now, in order to find out the trigonometric ratio sine 90 plus theta, we'll have to use the triangle OM prime P prime. So here we have sine 90 plus theta. So that's defined by, so we have perpendicular, which is P prime M prime, divided by the hypotenuse, which is OP prime. which will be equal to, so p prime m prime, we have defined that as x, where x divided by OP prime. So we are choosing the point P prime in such a way that OP prime, so let's write it down here somewhere, that OP prime equals to OP with a distance of r. Right. We can also prove that using the Pythagoras theorem, because OP will be square root of x squared plus y squared, and OP prime, that will be square root of negative y squared, which is positive y squared plus x squared. So that will be equivalent to r, each other. So this is x over r, and we have defined x over r as equals to cosine theta. So this will be cosine theta. So we obtained it sine 90 plus theta, that's cosine theta. Now we have to define for that so cosine 90 plus theta. So cosine 90 plus theta, we're going to use the same triangle OM prime P prime. So we have the base, which is OM prime, divided by the hypotenuse OP prime. The OM prime, we have defined that this is negative y. So we have negative y divided by r, and y over r. So that's sine theta. So that means cosine of 90 plus theta, that's negative sine theta. Fine. So let's note both of these two values, which will be useful to find out the other trig values. So we have obtained that sine 90 plus theta, so that's equals to cosine theta, and we have cosine 90 plus theta, which is equals to negative sine theta. Then we can also define the tangent function. So tangent of 90 plus theta, which will be the ratio of sine over cosine. That means we have cosine over negative sine theta, and that will be negative cotangent of theta. We can define cotangent of 90 plus theta. So cotangent of 90 plus theta will be the ratio of cosine 90 plus theta divided by sine 90 plus theta, so which will be negative sine theta over cosine theta. That's going to give us negative tangent theta. Right. We can define secant of theta. Secant of 90 plus theta. So secant of 90 plus theta will be, so we have 1 over cosine of 90 plus theta. So cosine 90 plus theta, that's negative sine theta, and the reciprocal of the sine function is the cosecant function. So we have negative cosecant of theta. And if we do cosecant of 90 plus theta, using the same technique, we're going to get positive secant theta. Right. So this is how we can define the trigonometric ratios 90 plus theta of each of the trig functions in terms of theta. Similarly, we can define this for 180 plus theta, meaning we can also define for sine 180 plus or minus theta, as well as sine 270 plus or minus theta, and so on. Now, we're not going to go with the proof because it will become extremely lengthy for this particular lecture. What we'll try to do, we'll try to use some mnemonics to remember all the angles, all the allied angles. So we started out with sine 90 degrees minus theta, and we obtained that this value is cosine theta. So the trick that we're going to use is we're going to write in terms of the radians. So sine 90 minus theta, that can be also expressed as sine pi over 2 minus theta. Now theta is measured in radians. In this case, theta was measured in degrees. So sine pi over 2 minus theta, so that's cosine theta. That means we're going to express this pi over 2 as 1 times pi over 2 minus theta equals to cosine theta. Then we obtained that sine pi over 2 plus theta, and this value was positive cosine theta. We've already found this value. And then we have sine 180 degrees minus theta, so that came up to be positive sine theta. How to make sense of all this value, we'll come to that. So 180, that's pi, so we have pi minus theta equals to sine theta. Now sine pi can be also expressed as 2 times pi over 2 minus theta, that's equals to sine theta. So this is very important. So that means we are always going to write our allied angles as a multiple of pi over 2. Meaning, so if we have sine, it could be anyone. I'm starting with sine. So if we have sine of 90 plus or minus theta, we're going to rewrite it as sine of 1 multiplied to pi over 2 plus or minus theta. If we have sine 180 degrees plus or minus theta, we're going to express it as sine 2 times pi over 2 plus or minus theta. Then if we have sine 270 degrees plus or minus theta. Then we're going to express it as sine 3 times pi over 2 plus or minus theta. Sine 360 degrees plus or minus theta. So this can be expressed as sine. We have 4 times pi over 2, because 4 times pi over 2, that's 2 pi, and 2 pi is 360 degrees plus or minus theta. The reason we are writing in this particular fashion, because we can then use the quadrant system. So in the first quadrant, we have 1 times pi over 2. Then in the second quadrant, it will be 2 times pi over 2. Third quadrant means 3 times pi over 2. Fourth quadrant means 4 times pi over 2. So whenever we have 1 multiplied to pi over 2, we're in the first quadrant. 2 times pi over 2, we're in the second quadrant. 3 times pi over 2, we're in the third quadrant. 4 times pi over 2, we're in the fourth quadrant. What if we have 5 times pi over 2? So that means we are actually in pi over 2 plus 4 pi over 2. So that's what it means. It's a pi over 2. So that means we're adding an extra pi over 2 to 4 pi over 2. That means to the fourth quadrant. And this is going to take us to the fifth quadrant, which is actually the first quadrant. So in simple terms, we can calculate. So 5 pi over 2 is 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and then we have 5 pi over 2. Then next will be 6 pi over 2, 7 pi over 2, 8 pi over 2, and this will go on. You can easily obtain in which quadrant you lie. So let's try to generalize this idea. Whenever we have sine, let's say we have an even multiple of pi over 2 plus or minus theta. So whenever we have an even multiple of pi over 2, such as 2 pi over 2, 4 pi over 2, like this. Let me write it down. 4 pi over 2, 2 pi over 2, 6 pi over 2, or you can even have 100 pi over 2. So these are all even multiples of pi over 2. Then in that case, our sine, that's going to remain as sine. So we're going to get sine, and we don't have to write this particular part, which is the even multiple of pi over 2. We'll straight away write this angle theta here. Then coming to the sign of this value. So it could be either positive or it could be negative. That depends on which particular quadrant we are in. Let's try to understand this with the help of an example. Let's say, for instance, we want to find out the value of sine 120 degrees. Now, how do we find out the value of sine 120 degrees? So sine 120 degrees, we can write it as 180 degrees minus 60 degrees. Now 180 minus 60, that's equivalent to 120 degrees. Now we will convert it to radians. So 180 degrees in radians, that's simply pi. And 60 degrees, so that's pi over 3. Now pi, this particular pi can be written as a multiple of pi over 2, which can be expressed as 2 times pi over 2 minus pi over 3. Now what do we have here? We have an even multiple of pi over 2. So according to this idea, so whenever we have an even multiple of pi over 2, then the sine function remains as sine. So we have sine, but this time we're going to consider only this particular angle. We don't have to consider 2 times pi over 2. So we have sine pi over 3. Now coming to the sine of this particular angle, is it a positive sine pi over 3 or is it negative sine pi over 3? So that's extremely important. We have to first understand in which quadrant 120 degrees lie. So this is going to help us understand. It's very simple. So since we have 2 pi over 2, the 2 pi over 2 means this is 1 pi over 2, which is the first quadrant. Then in the second quadrant, we have 2 pi over 2. So that means in the second quadrant, 2 pi over 2 lies, but then again from this we are also subtracting pi over 3 from it. Now pi over 3, this is an angle which is less than 90 degree. So when we're subtracting angle which is less than 90 degree from 2 pi over 2, we're still in the second quadrant. That means we have 120 degrees. So we are still in the second quadrant. So in the second quadrant, we have to remember the mnemonic, which is ASTC. So we know that in the second quadrant, the sine function is positive, everything else is negative. So since we're dealing with our sine function, we started out with sine function, thus final value. Don't look at this sine value, the final value is always positive. And sine pi over 3, that has a standard value of root 3 or square root of 3 over 2. So this is going to be the value of sine 120 degrees. Now there is another way of doing this, and we'll also obtain the same result. This is going to help us understand the power of this idea. So sine 120 degrees, we can also express it as sine 90 degrees plus 30 degrees, because sine 90 plus 30, that's also 120 degrees. But this time what we have, So we have 90 degrees, which is pi over 2, and 30 degrees, so that's pi over 6. Now we have an odd multiple of pi over 2. Now this comes to the next idea. So that means whenever we have, so let me write it down, sine, and we have an odd multiple of pi over 2 plus or minus theta. We have to be very careful. So whenever we have an odd multiple of pi over 2, so that means 1 times pi over 2, it could be 3 times pi over 2, it could be 7 pi over 2, or anything. As long as this is an odd number, then our sine will become cosine. So sine is going to become cosine, and we don't have to worry about this particular part, only have to mention this angle theta. Then coming to the sine, so it could be either a positive sign or a negative sign. That is going to be dependent on which quadrant we are lying. That means in which quadrant this entire angle lies. Fine. So let's try to do this problem. So here we have sine 1 times pi over 2 plus pi over 6, so 1. So that's an odd multiple of pi over 2, which means that our sine function gets converted to a cosine function. So we have cosine. So now we don't have to worry about this first part, the pi over 2 part. Only thing we have to do is mention the second angle, which is pi over 6. We'll also have to be careful about the sign in front. So we'll first understand in which quadrant this angle lies. So I've already mentioned that we are in the second quadrant. In the second quadrant, the sign is positive. So now it's a tricky question here. So we will say that since sine is positive and we have a cosine here, that's a negative. No, we never look at the final answer. We'll only look at the beginning of the answer or the original problem. So in the original problem, we started without the sign. So the sign, whatever be the value, the final answer is only dependent on the original value. And since this is a sine function, so we're going to get a positive value. And what is cosine pi over 6? So that's square root of 3 over 2. So we have obtained the same result. Now that we have understood this idea, we can point out all the angles. So let's begin. So I'll start with sine 90 minus theta, or simply sine pi over 2 minus theta. So here we have an odd multiple of pi over 2. So whenever we have an odd multiple of pi over 2, so we're going to get cosine theta. So we're going to get cosine theta. Now we will come to the sine at the end. So let's first note down everything. If we have cosine of pi over 2 minus theta, so since it's an odd multiple of pi over 2, so cosine will change to sine and the angle will be simply theta. What about tangent? So tangent of pi over 2 minus theta. So the tangent must change, so it will become cotangent. So tangent will become cotangent. Cotangent of pi over 2 minus theta. So cotangent will become tangent theta. Then we have secant theta. So we have secant of pi over 2 minus theta. So secant will become the cosecant function. So we're cosecant of theta. And cosecant of pi over 2 minus theta. So that will become secant theta. Now, in which quadrant does pi over 2 minus theta lie? So that means we are in the first quadrant, pi over 2. And we are also subtracting some angle theta from it. So subtracting the angle theta means we are still in the first quadrant. And in the first quadrant, all trigonometric functions are positive. So that means all these values are going to be positive in nature. Now, let's try to do the sine when the angle is 90 plus theta. So we start out with sine pi over 2 plus theta. So let me note down each and everything. So we have an odd multiple of pi over 2 in each case. So sine will get converted to cosine. So we have cosine theta. Cosine will become sine theta. Tangent will become cotangent of theta. Cotangent will become tangent of theta. Secant will become cosecant of theta. And cosecant of theta will become secant of theta. Now here the sign is going to be extremely important because this time we are going to be in the second quadrant. The reason behind this is we have pi over 2. 1 pi over 2 means we are in the first quadrant, but then again we are adding an extra angle theta to it. So 90 degrees plus theta, because from 0 to 90 degree we're in the first quadrant. If we add some theta to it, so that takes us to the second quadrant. And according to our quadrant system, we have ASTC, where S means only the sine function and the cosecant function is going to be positive. In this, we have a sine value which is going to be positive and the cosecant value. Always be careful. Always look at the original trigonometric function, not the final answer. The cosecant function, that's going to be positive, and blindly we can put a negative sign in front of the 4 trigonometric ratios. All of them are going to be negative. Next, we will try out with 180 plus or minus theta. So we have sine 180 degree, which is pi minus theta. Now sine pi minus theta can be also expressed as sine 2 times pi over 2 minus theta. Now luckily we have an even multiple of pi over 2. So whenever we have an even multiple of pi over 2, sine will remain as sine. So we're going to have sine theta. Let's complete the remaining as well. So we have cosine of 2 pi over 2 minus theta. Then we have tangent of 2 times pi over 2 minus theta. We can have cotangent of 2 times pi over 2 minus theta. Secant of 2 times pi over 2 minus theta, and cosecant of 2 times pi over 2 minus theta, which will be equals to, so we can find out each of the values. So whenever we have an even multiple, the function, the trigonometric function, does not change. So cosine will remain as cosine, and then we are going to have theta. Tangent will become tangent. So we have tangent of theta. Cotangent will remain as cotangent, cotangent of theta. Secant will also remain the same, secant of theta. Cosecant will also remain the same, so we have cosecant of theta. Next comes the sine. So we will draw our quadrants. So in the first quadrant, second quadrant, third quadrant, and fourth quadrant, where does pi minus theta lie? So pi means what? 180 degrees, which means we are in the second quadrant. So in the second quadrant, so this is 90, 90 plus 90, that's theta. So this entire angle is pi radians, and we're subtracting a small angle from it. So whenever we are subtracting a small angle from this theta, as long as this is greater than theta, so let me mention here, this theta is greater than 90 degrees, but that's less than 180 degrees. That's very important. Then we are going to lie in the second quadrant, and since we're still again in the second quadrant, we know that only the sine function and the cosecant function, that's going to be positive. Everything else is going to be negative. So that means the final answer of sine theta, that's going to be positive, and final answer cosecant, that is going to be positive. Everything else will be negative. I hope it is getting clearer. Now we're going to next one, which is sine of pi plus theta. So since we have an even multiple of pi over 2, so sine 2 pi over 2 plus theta is going to give us sine theta. Cosine 2 pi over 2 plus theta will remain as cosine theta. So the trig functions are not going to change. We have tan theta, cotangent theta, secant theta, and cosecant theta. Now we'll come to the sine of each of the angles. So we have a quadrant system. We have our first quadrant, second quadrant, third quadrant, fourth quadrant. So 2 pi over 2 means we are in the second quadrant, 2 times pi over 2. But this time we are adding theta to it. So adding theta to means we are adding an extra angle to pi. So that takes us to the third quadrant. So this is where we are lying. And according to the mnemonics A, S, P, C. Now in the third quadrant, 3 means we have tangent and its reciprocal, the cotangent function. So these are going to be positive. Everything else is going to be negative. So we'll look for the tangent and the cotangent. So these two are going to be positive and everything else are going to be negative. Fine. Now we have found out the value of pi plus theta. Now we will come to the next one, which is 270 plus or minus theta. So we'll start with sine 270 degrees minus theta. So 270 degrees in radians, so that's 3 pi over 2. So we have 3 pi over 2 radians minus theta radians. Now here we have what? We have an odd multiple of pi over 2. So we have to be very careful. Whenever we have an odd multiple, sine will get converted to cosine. So we'll have cosine of theta. Then similarly, we have cosine of 3 pi over 2 minus theta, odd multiple of pi over 2. So cosine will become sine. So we have sine theta. Then we have tangent of 3 pi over 2 minus theta. So tangent will become cotangent. We have, because we have an odd multiple of pi over 2. Cotangent of 3 pi over 2. So that changes to tangent theta. Secant of 3 pi over 2 minus theta. So that becomes cosecant theta. And finally, cosecant of 3 pi over 2 minus theta, so that will be equals to secant theta. Now coming to the sine, so what is 270 degrees minus theta, or 3 pi over 2 minus theta, which means we have 1 pi over 2 lying in the first quadrant, 2 pi over 2 lying in the second quadrant, 3 pi over 2 lying in the third quadrant. So we have to also subtract theta from it, but we have theta is a very small angle lying between 0 and 90 degrees. that means it's less than 90 degrees. So that means this is still going to lie in the third quadrant, where only the tangent and the cotangent are positive, everything else is negative. So we'll look at the functions of tangent and cotangent, keep it positive, and where everything else will be negative in sign. So we have sine 3 pi over 2 plus theta, that will become cosine theta because we have an odd multiple of pi over 2. 3 is an odd number. So we can list out all the remaining trig functions. Now coming to the sine part, so 3 pi over 2 means we are in the third quadrant. But this time we are going to add another angle theta, theta to it, which takes it to the fourth quadrant. Now in the fourth quadrant, we know that we have A, S, T, C. So C stands for cosine and its reciprocal, which is the secant function. So these two are going to be positive, everything else is negative. So look for the cosine and the secant, keep them, the final answer as positive, and everything else will be negative. Again, you have to be very cautious. Don't look at the answer that you have obtained here secant and cosecant where the negative. No, we only have to look at the original trig function where with which we started out with. We started out with cosine and secant, so they are going to be positive. Everything else is negative. Now coming to the final two ones, which is 360 degrees minus theta. So we have sine 360 degrees minus theta. So 360 degrees in radians, so that's 2 pi radians, and 2 pi can be also expressed as 4 times pi over 2. So 4 times pi over 2 means here, 4 being an even number, we have an even multiple of pi over 2. So whenever we have an even multiple, so the trigonometric function does not change. So sine 4 pi over 2 minus theta will remain as sine theta. Cosine 4 pi over 2 minus theta will remain as cosine theta. So let's write all of them. So we have tangent theta, cotangent theta, secant theta, and cosecant theta. Coming to the quadrant, so we are going to be in the fourth quadrant. So we have 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And from 4 pi over 2, we are subtracting negative theta. That's fine because theta is a very small angle, less than 90 degrees. So we are in the fourth quadrant where the cosine and the secant function, they are positive. So look for the one which have cosine and secant, keep it positive, everything else will be negative in nature. Fine, so that's fine done. Then finally, I'm leaving 360 degree plus theta as an exercise for you, because sine 360 degrees plus theta, which is nothing but sine 4 pi over 2 plus theta, 4 pi over 2, that means an even multiple of pi over 2, we're still going to have sine theta. Now, what is 4 pi over 2 plus theta? That means we are back to the first quadrant where everything else is positive. Right, so it resets itself. This is how we can obtain the trigonometric values of different allied angles. We're ending the session here today. We will be picking up in the next session and working on some numericals that is going to help us understand these ideas in a much better way. So see you in the next session.